So hi, I'm Maurice. I'm a LND maintainer. I'm going to explain what it is now soon. I'm a Spiral Green Tea, and also I'm part of the V4S Live Satoshi team. You can find me there on Twitter. So today my my talk is mostly trying to convince you, if you run an LND node, to try to run LNDK too. So it has like a workshop inside the presentation. But if not, I'm going to explain how we do it. It is not magical. It's just doing the right stuff on the right time. So, little agenda. So why BOLT12? So what is going on in LNDK? What's new on B0.3 that launched like last month? And a little demo. So if you want to do some coding, or if you want to give someone like a good way to start trying it out before running it like in production, you can go to that URL and just do it like hands-on if you want it. So why BOLT12? First, I think it has a better UX for payments. You could use like reusable QRs, auto withdrawals. We can have like a contact scenario, like any PayPal or Venmo app should do it using BOLT12. It also has like protocol accessibility. We could use like recurrent payments in the future, or we can add other stuff on the spec so it can be done using this. And actually, as Elias talked before, actually fixes the privacy and censorship problem that current has. Because of onion messages, does not rely on HTTP servers like LN URL, that they can be censored, and also root blinding. Let the receiver do not show herself when in a payment or when they're receiving onion messages. So the big thing here are blinded paths, what were introduced on BOLT12. It looks mostly like this. We have an introduction node that is in the beginning of the path. We have blinded hubs for each node. This is completely the blinded path. And the receiving node is in the end. And it could be like this, be like the same node itself, repeating itself and not being any forwards on that. Or this can be like different nodes that they are forwarding like onion messages between them. So this is the offer flow. In general, above does create this structure that is called offer that has 1 to n blinded path on it. Alice will use a QR code to scan it. It will require to create this invoice request, TLV, with its own blinded path. Send it through the onion message blinded path of Bob. Then Bob will need to create this invoice message with his own set of blinded path, and that's for until the payment is made done through this blinded path. So BOLT12 kind of fixes the privacy and censorship problem on this stage, because if we see it like right this way, we need to build like different part of the system, and everyone needs to support it so we could start using it. So first we need everyone to start building this kind of structures, and so they can be shared between each other. We have to have onion messages forward to be supported broadly so we can hide between this node and network. And also we have to have the forwards of HTLCs using blinded path that is kind of the same, but they're built different in each implementation. So just paraphrasing what Matt says in a few years ago, they were saying like privacy isn't that bad, just use BOLT12 and not LND. I want to try to explain why he was saying about that. If we see all these structures that I was mentioning, all the 3 implementations kind of already implemented, except for these 2, like LND also implemented, like forwards of HTLC, you can do it with BOLT11 and LND. And invoices in BOLT12, they are kind of the same in BOLT11. Okay. So LND already implements that. So you can actually translate the BOLT11 invoice to the BOLT12. It's quite easy and straightforward. So this one were already implemented for LND, so everyone in the network can use it. But this one you cannot do it, and only these implementations are doing it. So that's what I say. If we need to fix the privacy problem, we need to do the network effects. And if we go to the Elias presentation, it's 5.6% of node supports onion messaging. And mostly because LND market share is quite like over 80% or something. I don't know the number, but it's my suggestion about it. So we need to do something about it. So here comes LNDK. What is it? It is a little thin server that is like a sidecar that runs next to your LND server. and mostly use LDK for every functionality of like heavy work. So it's a shame because it intercepts calls from the LND side, translate it, do something about it, and then it's going to be used in the LDK back and forth. So LND is mostly like a messenger in this case, and LDK does the heavy part of signatures and everything related. I think it's like a little Frankenstein, but I think also it's quite clever how it's done. Today, you can, if you run LNDK next to your LND node, that I will show how quick it is, you can have onion messages routing, like forwarding, you can pay BOLT12 payments, and now you can generate offers and receive payments through it. What's next? We already built the BIP353 payments, and merchant pay user flow, they're coming in the next version. Afterwards, we don't know yet what's going on about the project. So with that, currently with the latest version, we can have all the structures, all the TLVs, and we can do all the payment flows of BOLT12. So that's a great win for the network itself. So instead of just saying that words of math, maybe it's like use LNDK with your LND node and you can use BOLT12. It's not like that hard of a statement. So I'm going to explain now how it is done inside of LNDK. What are the things that we're doing so we can maintain LNDK as stateless as possible and as simple as possible to be running next to your LND node. First, we need to, on the spec of BOLT12, you have to do some signatures, not the offers, but all the invoice requests and the invoice needs to be like signed. For that, one option was to have a set of key instructions inside of the LNDK, but we wanted to do it as stateless as possible and just run it. So we stole the idea from the blips, BIP50 actually, that they use like this kind of message that is going to be signed on LND with a specific seed key family and a specific key index. With that, we just hash it, the answer, and then we can have like this stateless state that is of a seed, so we don't have to store it. We also only ask for the node to sign something and then use that as a seed, so to do all the signatures that is required on the offer flow. So that I think is quite clever. Now, before we were doing that, every time you restart an LNDK, that's what is happening currently in the strike. Every time you restart, they generate new keys, so they cannot state. They cannot know if the invoice request that they're coming is from an offer from themselves. But with this, we could actually restart the server with not state. Then, I'm going to try to explain how we do the onion handling, onion messages. We only use this lightning error RPC from LND. We subscribe to peer events. We subscribe to custom events type. That's why we, on the LND side, they can handlers us the onion messages. And we use the send custom message to send the onion message. Actually, there are just sending operations. Whenever we see a subscription, a peer event, we will enqueue the peer connect and the peer disconnect events into a general queue of events, and that we are going to feed the onion messenger in the LDK side that is going to build like what is in our neighbor on the network. And whenever we see a message from the LND, like it's incoming message, we are going to feed it also to the onion messenger, and it will handle the onion message itself. It's going to decrypt it, see what we need to do next. That it could be like either it's a message for us or we need to actually forward it. So if we need to forward a message, the handle onion message, we're going to enqueue the new message to be sent. And every 100 milliseconds, we are going to enqueue a send outgoing for each peer. So we're going to just process each message differently for each peer, and we're going to use the send custom message in the NC. So it's mostly just LND trigger our queue triggers onion message, and then onion message trigger another queue, and we are just sending it back. So it's pretty straightforward. Yes. So this is how we get invoice internals. So we can say like what is mostly doing we are doing on LNDK side. Whenever we receive like a pay offer or get invoice in gRPC request, we just decode it, try to understand what is going on. We're going to try to blinded path. For the invoice, we just list the peers, and we randomly select 3 of them. When we have the peers, we build the blinded path, and then we build an invoice request that is mostly like the TLV that we're going to send. We build the invoice request. LDK, what this does, it takes our key that we already have it, like the seed, is going to sign it, build the onion message. We're going to enqueue the onion message and just send it through the network. Then after 100 milliseconds or so, we're going to receive a message, like an onion message from to the LND. We're enqueuing it on the onion processing queue. LDK just process it, and we are done. Like we will have the invoice to be paid. Finally, when we have the invoice, we can pay it through using the gRPC, or we can pay the offer. It's going to be automatically. We're going to decode the invoice. We're going to request the query routes and the LND side using the path that is provided in the invoice. And we just do like the sequence of paying like BOLT12 invoice. We're going to send the payment. We're going to just track payment V2 or something, and we wait for the result. And the payment should be done using like the common way of doing it on LND. So this is the same exact flow on the strike side. I didn't like that much, but it actually shows the full paying offer. We're going to, from pay offer, decoding, creating the request, sending the message, waiting for the invoice to come. We have a timeout for that. We subscribe, we track the invoice, and we just return when it's paid. So I'm just going to do the same demo for you guys for now. This is like the first link that I just showed. You can then ask me if you wanted to do it. We're going to set up this is what it's doing, is building a network without like using Polar. I'm spinning up a LND Eclair 1, Eclair 2, and CLN network. It's going to create the channels automatically. It's going to wait for the peers appears in the graph network. Actually, there is validating the node graph, so we are waiting for that. It shouldn't take that much. So afterwards, I'm going to use this handy script. Hopefully, it doesn't take that much. Oh yes. So we want all the nodes to have where are actually in the network. So it sometimes takes to just make the network sync. So live demo. Okay. Well. Okay, so we have all the node info, and we already copied the secrets wherever I needed to. I don't know if, yeah, I think it. So if we run ln CLI list peers, LND should have like 3 peers. There's 1, there is 2, and there is 3. So we have 3 peers. If we list payments, we shouldn't have no payments on LND. We just set up. So I'm going to just run the LNDK server. What we're doing, we start in direct test network for node that we fetch, and we are just connecting to the subscriptions that I already told. So we're waiting for that. We're going to fetch an Eclair offer from the network, and then we're going to get invoice. So we are running the LNDK CLI command, and it shows like the decrypted invoice. We are not using the invoices in BOLT12 doesn't have a standard way of showing off. We're just using the hex string. And if we want to just pay the offer, that is going to fetch the invoice and then we just pay it. It's going to do exactly the same. It's going to fetch, and then we're going to and successfully pay the offer. And I can show you that I'm not lying. We list the payments again. This is the latest one. It succeeded, and we actually paid an offer using all the scheme that I already showed. So that's one thing. You can try it out afterwards if you want it. So then how I can receive payments using the same. So how does it work? First, we need to solve statelessness, because LND does not store BOLT12 and LNDK doesn't have state. So we need to store somehow and know when the offer is from us. So one way of doing it, this is stolen from LDK side. They were first doing adding on the TLV metadata, where we were adding anons, and we could calculate using the TLV records and HMAC. Also added an encrypted payment ID so we can query faster. And using this, we could actually maintain the statelessness and not store in a database which one were our offers. But this has some issues, because if we don't authenticate actually the blinded path, we could de-anonymize the offer, like correlating two offers is from one specific person or node, forging like custom invoice request. So in order to solve that, what we started doing is actually doing kind of the same, storing anons and also an HMAC, calculating an HMAC and put it inside the blinded path hub receive, and on the blinded hub that is receiving, that is actually us, we're adding a new TLV that we can recalculate it. So we kind of, for each blinded path that we created, we have a way of authenticating that the user used that blinded path specifically that we built, and we only know that we built. So in that way, we maintain the statelessness, and we don't have to store anything in a database. So knowing that, what we do for create an offer is quite straightforward. We receive a gRPC. We start by building our blinded path. For that, we list our channels, because we want to have like, channels are the most conservative way of connecting to peers. So we use that because offers can be like long, they can last longer. So we use that, we build the blinded path, then we build the offer itself. We don't need even to sign it. We build the offer and we return the offer. And whenever we receive an invoice request through the onion message, what we do is when queue the onion processing, the onion processor will know that we are receiving this, they are asking for an invoice. We should authenticate the invoice request with the trick that I already told you. We then create an invoice for the invoice request. We create a BOLT11 invoice using the blinded path options in LND. Then using that, we parse the BOLT11 and just transform it in what is BOLT12. Then we queue the invoice to the onion processing handler, and we send the outgoing message. And finally, the payment arrives like any other payment, like BOLT11 payment that LND was waiting for. So, just to show off that I'm not lying, I'm going to just run the script, create an offer, and what it did was ask for the channels, then create, and it's quite big compared to the Eclair, because the Eclair one wasn't adding that many blinded paths. We tried to build like 3 unique blinded paths for this route. So then we can use the CLN, for example. And for a CLN, they do it differently. You have to request the invoice and then pay it. So I'm going to do that. And there you go. Payment is complete, destination, the payment hash, and how many parts. So we can just do list invoice, and we could see like the same invoices as the BOLT11. We have one settled here. So we are receiving actually the BOLT12 payment through that. So cool. And you can see that down there. And wrapping up, so BOLT12 is important for Lightning privacy, censorship resistant, and also better UX. LNDK is important in the ecosystem, so we can accomplish that. You can run it now. You can start receiving payments now. Even if you are not using BOLT12 payments now, you can help the network just running it. And actually, you have my local development, so because I just spin up networks like this, and you can hack around LNDK like stressless without using money. So thanks. You can ping me on Twitter. Questions?
Any questions? Yeah.
Thank you for explaining how LNDK works. I have two questions. One is, will you keep maintaining LNDK after BOLT12 is merged in LND? Or like what does the future look like?
Yeah, it's quite, actually, we don't know yet. For the first part, we will keep maintaining it, but we are thinking to add also other features that are not in LND. For example, async payments is a thing that we are currently looking at, and we probably continue on that path for the next year or so.
And okay, so my second question is, do you in any way mitigate the DOS vector of like if somebody's doing a lot of onion messaging, do you have some way to protect your node against too much traffic?
Yes. Or, yes. So that one was one of the main issues in the beginning for Strike. That Strike is running this. So we added a rate limiter inside the LNDK. So we are trying to, if we have so many messages from one peer or to one peer, we're actually rate limiting inside it of the queue, and queue also has like a specific fixed size of it. So we are not, we haven't had that many issues related to the OS attacks. Cool. Here was one question.
Yeah, thanks for the presentation. Is there a reason why LND is not interested in this? Is my first question. The second one, are you considering doing splicing or anything like that that LND doesn't have as well? I know that's a big one.
Yeah, I think I cannot talk from LND, but they are working on it. I saw some PRs on onion messages. I thought they were going to be launched on 0.20, like this is the current version. I think it didn't land. Hopefully it's in the next 3 months. I would like to see this like implemented like natively in LND. This is our hack around, or my hack around, to just make it happen. And in the splicing side, I think it's harder to implement it like this kind of outside, because you have to do like, I don't know the specifics of splicing, but probably you need to do something related to the scripts and all that. That is pretty embedded in LND. It's not like that practical to have it outside. Cool. Some question? No? Okay, thank you very much.